In problem number 8, they've said a projectile is released with an initial vertical velocity of 100 meters per second. It was nice of them to tell you that, but then you don't really need it, because in the next sentence they turn around and they tell you the velocity function right here. So that initial velocity might have been nice to know if we had to come up with our own velocity function, but because they gave it to us here, that really wasn't necessary. This constant value in the velocity function is always going to be your initial velocity. Okay, so that's what we've been given here. They told us the velocity function, and they want us to determine the distance traveled during the first 15 seconds. Well, we're going to make this one nice and easy, guys. When they say distance traveled, we use the phrase total distance traveled here, and we've got a formula for this, guys. It was the definite integral from a to b of the absolute value of your velocity function taken with respect to t. If the directions specifically said we had to do this without using our calculator or without an absolute value function, then it becomes a slightly different matter. I'll walk you through that in a minute. But for this one, it's pretty straightforward. We're talking about the distance traveled in the first 15 seconds. So that means that we're going to begin measuring at t equals 0, hence the first 15 seconds, and end that thing at t equals 15. And then we would take the absolute value of that 100 minus 9.8t in an absolute value sign right there, and take all that with respect to t. So let's go ahead and answer the question here, guys. We don't need to spend too long on this one. So let's take a look here. Tools, and we're going calculus 4 and then 3 for an integral. We are going from 0 up to 15. And then for our integrand right here, all right, again, we had to do the absolute value right here, which, do I know how to do it on this calculator? Let's take a look. That might be, I will make this easy, guys. I'm just going to type in the ABS right there. So, I thought I was. Now I've lost my keyboard. Oh, I'm in trouble. All right, here, and there we go. No? Maybe? ABS, and I think that will work. Okay. What? No. All right, ABS. Let me go back to the keyboard that I had before now, the numerical one. Sorry, guys. All right, that'll go here. All right, and then we can put a parenthesis right there, and that should work for us. So our velocity function was 100, and then a minus 9.8. We had a t coming right after that. Gotcha. And we're doing all that with respect to t. So I think we're going to find out quickly here if the calculator likes what I typed in or not. Let's go ahead and hit enter. Yeah, it converted my ABS into an absolute value sign, and this is the answer we were looking for, I believe. 622 point, we're always going to go to 3 places here, guys, 0.908. So 622.908. And if we think about units right here, let's look at our integral. This function right here was measured in meters per second, but that now gets multiplied by dt or delta t, and the 0 and 15 were being measured in seconds. So the meters per second times seconds, the seconds cancel, and we end up with just plain meters for our answer, which is a pretty logical answer here for total distance traveled. So that's the answer to this problem. And if you want, you can shut this video off and stop listening right now. I will just say real quickly, you could have done this problem a different way, and here's how. Our velocity function right there is linear. I think we can tell that. And that means that our position function would be quadratic. So this probably shouldn't surprise you guys, because we did some work on this back in chapter 3. It looks like we're taking an object and we're launching it up in the air, and then it's coming back down, and it's basically going to take a parabolic shape right there. Now at this spot here, the apex, that is the spot right there where the velocity of our object is equal to 0. So if I had set this equal to 0 and solved, let's make this nice and easy, guys. 9.8 is pretty close to 10. Now if it were 10, that would have given me a value of 10 for the answer. As it were, it probably needs to be just a little bit bigger than 10. So let me just say t equals, I'm going to take a guess here, guys, 10.1. Okay, that is when this would happen right up here. T is equal to 10.1 seconds. So what we could have done, another way right here, guys, is total distance traveled is, we could have taken a look at the displacement of the object just on its upward trajectory. that would have been an integral from 0 to, okay, roughly 10.1, whatever it was, of your velocity function with respect to t. And that would have told you how far the object moved just on its way up. But then, going to 15 seconds right here, we would have had to consider how far it went right there. So we'd have to add to that an integral that starts at 10.1 and ends at 15 of the same velocity function with respect to t, except for one problem. On this part going down right here, the velocity is negative, and that means that your displacement would be negative as well. We would actually need the opposite of that negative displacement right here. So I would just change that plus right there to a minus. And I'm pretty confident, guys, that if we typed that into our calculator with the right value here instead of what I just made up, that would get us this exact same answer right here of 622.908. So both ways of doing that are going to get you the correct answer, but pretty obviously that first one using absolute value is going to be a lot faster and easier, assuming we're allowed to do that. And if I gave you a problem like this on a test, or if the AP people gave you this problem, yeah, they would likely let you use your calculator on that problem as well.